This is the hybrid part of section 9.2. So we're on example 2. And while I realize that a lot of this might look really confusing, I'm going to interpret all of it for you as we go. So you're given that cosine alpha is negative 15 over 17, sine beta is 4 over 5, with alpha between pi over 2 and pi, and beta between 0 and pi over 2. We're going to find and simplify the exact value of the following. Now, a few things to notice here. Because this is a cosine, this is telling you that this is adjacent over hypotenuse. Because this is a sine, this is telling you it's opposite over hypotenuse. These inequalities are telling you which quadrant those angles lie in. That alpha is between pi over 2 and pi tells you it's in quadrant 2. That beta is between 0 and pi over 2 tells you that beta lies in quadrant 1. So you just have to be able to extract all that information from what's given. So if we want to find sine of alpha plus beta, first and foremost, you cannot distribute trig functions. This is not just sine alpha plus sine beta. You want to refer to the formula sheet that I gave you for sine of alpha plus beta for that formula. So this is what I pointed out earlier, that this means that alpha is in quadrant 2 and beta is in quadrant 1. From the formula sheet, sine alpha plus beta is this formula. Do not distribute that sine function. It is very, very tempting, but you cannot do it. All right, so we have to draw those angles in the appropriate quadrants. So beta is in quadrant 2, alpha is in quadrant 1. Using what was given to us, for beta, we were given that sine is 4 over 5. Remember, that's opposite over hypotenuse. So opposite over hypotenuse. Using the Pythagorean theorem, we know that if this is 4 and this is 5, that's going to be 3. Same thing for alpha. We're given cosine here is negative 15 over 17. That's adjacent over hypotenuse. So adjacent, is that negative? That makes sense since we're going to the left. 17 is the hypotenuse, always positive. Using the Pythagorean theorem is where we get that 8 from. When we get plus or minus 8, we know it's positive 8 because in quadrant 2, we're going up. So that's a positive 8. Once we get those triangles drawn, it's just a matter of plug and chug. We have this formula, so we just have to plug in those 4 values. So sine alpha, we look at the alpha triangle, sine is opposite over hypotenuse. Cosine beta, we look at the beta triangle, the cosine is adjacent over hypotenuse. Plus, cosine alpha was given to us in the original problem up here, and sine beta also given to us in the original problem, or we could get them from the triangles, either way. Then just grab a calculator, multiply those 2 fractions, you get 24 over 85. Multiply those 2 fractions, you get 60 over 85. We're going to subtract those because of that minus right there. So we get minus 36 over 85. Now that we have those triangles, part B is going to be a little bit easier. Cosine alpha minus beta, again, do not distribute this. You want to look at this formula sheet for the minus, that's the bottom sign. So it's cosine alpha, cosine beta, plus sine alpha, sine beta. So there's the formula. Then again, we're going to look up here at those triangles and just fill in the values. Cosine alpha was given to us in the original problem. Cosine beta, we're going to look at beta. Cosine is adjacent over hypotenuse, so it's 3/5. Sine alpha, sine is opposite over hypotenuse. And then sine beta was given to us in the original problem. Multiply that fraction together on your calculator. Multiply that fraction. Remember, when you multiply fractions, you multiply straight across the top and straight across the bottom. And then we're going to add those 2 together. We'll get negative 13 over 85. So everything in this problem hinges on you correctly identifying which quadrant those angles are in and correctly labeling those. If you put these in the wrong quadrant or you mislabel these, everything falls apart. from this. So you got to be super duper careful right here at the beginning and make absolutely sure that you get that stuff correct. Right. And then lastly, part C here. Tangent alpha plus beta, looking at our formula sheet for tangent alpha plus beta, we get this formula. And then we're going to use the same right triangles from the previous page. We're going to look at the alpha triangle and find the tangent. The tangent is opposite over adjacent. So it's 8 over minus 15. The tangent of beta, we're going to look at the beta triangle. Opposite over adjacent is 4 over 3. And then tangent alpha, tangent beta. And then we just have to simplify this. So if you grab your calculators, add those two fractions, you get 4/5. 1 minus the product of those two fractions is going to be 77 over 45. And then you'll want to divide those out. So here's what happens right here. This big old fraction bar right there is the same as that division symbol. So you just need to divide those two fractions, and there you go. So let's do some inverse stuff along with these sum and difference formulas. So the cosine of the inverse tangent of 5/12 minus the inverse cotangent of 4/3. Now, just like before when we were doing the inverse trig functions, remember that an inverse trig function is an angle. So I'm going to call this one alpha, and I'm going to call this one beta. Before, I just called it theta because it was just one angle. But normally, if I have more than one angle, I'm going to call them alpha and beta. All right, so let's just get started. If alpha is that inverse tangent of 5/12, then that means if I take the tangent of both sides, I get tangent alpha is 5 over 12. That tells me that it's in quadrant 1 because of the domain restriction on the inverse tangent. So I get alpha's in quadrant 1. This tangent is opposite over adjacent. And then using the Pythagorean theorem, you might recognize 5, 12, 13 as a common Pythagorean triple. But if you don't, that's okay. You can use the Pythagorean theorem to get that. Okay? And then beta was this inverse cotangent of 4/3. So we're just going to go through all this again, but with beta. So we take the cotangent of both sides. We get that because this is positive, it's also in quadrant 1. So beta being in quadrant 1, the cotangent is the adjacent over opposite because it's the reciprocal of the tangent. So we get that 4 over 3, and then you might recognize that Pythagorean triple of 3, 4, 5. Now, all that stuff done, the cosine of alpha minus beta. Now, why did I use that formula? Because this was the cosine. I let this be alpha and this be beta. And it's a minus right here in the middle. Using the formula for the difference of, the cosine function here, we get cosine alpha, cosine beta, plus sine alpha, sine beta. This is the formula from your formula sheet. Then I just have to go back to those triangles and find cosine alpha. So I'm going to go up here to the alpha triangle. Cosine is adjacent over hypotenuse. Cosine beta, adjacent over hypotenuse, using the beta triangle. Sine alpha, and use the alpha triangle, it's opposite over hypotenuse, and then sine beta, use the beta triangle, opposite over hypotenuse. Multiply those two fractions together, add them up, we get 63 over 65. The tough part of this one is knowing what to do with those inverse trig functions, that you have to do two different triangles here, and then you have to utilize that cosine alpha minus beta formula. That's what makes this one trickier. And now it's on to some identities. Those are going to keep creeping back in this chapter. I know you love them. This is the sine of alpha plus beta. And we're going to start on this left-hand side because it's more complicated than the right-hand side. So because this is that sine alpha plus beta, where alpha is x and beta is 3 pi over 2, I used that sine of alpha plus beta formula. Do not distribute that sine. I cannot say that enough times. Don't distribute the sine or cosine or tangent. So we get sine alpha cosine beta plus cosine alpha sine beta. And then plugging in for alpha and beta there. Now 3 pi over 2, that's a constant. So we can actually find the cosine of 3 pi over 2. You can use your calculator for that if you want, or you can use a graph. But that's 0, and the sine of 3 pi over 2 is -1. So that being 0 zeroes out that entire term, and that being -1 is going to give me negative cosine x. And just like that, we're done. Quick and painless. Okay, next up, verifying the identity. This one, we're adding the cosine alpha plus beta formula to the cosine alpha minus beta formula. So we're going to start on this left-hand side. Now you can see that I color-coded this for you. The red right here is the cosine alpha plus beta formula. The blue is the cosine alpha minus beta formula. And from the formula sheet, I'm using these cosine formulas. These two terms are like terms. They have different signs, so they're going to zero off. These two terms are the same. They both have a coefficient of 1, so when I add them together, I'm going to get a 2. And just like that, done. So this one looked like it was going to be a lot worse than it really was. Last example for this section. We have sine alpha plus beta over sine alpha minus beta equals tangent alpha plus tangent beta over tangent alpha minus tangent beta. Whew! All right, where do we start? Which way's worse here? This is tough. I don't know. I'm going to start on the right-hand side just because of all those tangents in there. Okay? So what I chose to do was start on the right-hand side, and I chose to change all those tangents to sines over cosines. So I got sine over cosine, sine over cosine, sine over cosine, sine over cosine. Now, just like I mentioned before, with complex fractions, which is what this is, you want to multiply by that least common denominator of the 4 smaller fractions. So this little fraction, this one, and this one, which are all part of this bigger fraction. So the least common denominator is cosine alpha, cosine beta. So I multiply by that over itself. So notice how I did that in red. And then this is the hot mess express that comes as a result of distributing cosine alpha, cosine beta to both of these and both of these. So this is where you might want to just kind of pause the video, take a second, and try to be like, okay, I see what she did. She took this fraction times the red stuff, plus this fraction times the red stuff, this fraction times the red stuff, minus this fraction times the red stuff. And then the canceling begins. Cosine alphas cancel here, cosine betas cancel here, alpha's here, beta's there. And what I'm left with on the top here is sine alpha cosine beta plus sine beta cosine alpha over sine alpha cosine beta minus sine beta cosine alpha. And believe it or not, just like that, we're done. Because this top here, this numerator, is the formula for sine of alpha plus beta. The bottom is the formula for sine of alpha minus beta. So just like that, we're at the left-hand side. It would have been a lot trickier to start on that left-hand side, expand these formulas out, and then try to figure out a way to get that tangent to show up. So going the opposite direction's doable, but I feel like it's a lot trickier and requires a little more finesse than you might want to do. So I feel like this is a little bit better way. So, okay. So this finishes up the hybrid portion of section 9.2.